So what we're going to look at in this lesson is, are there shortcuts to figuring out if two triangles are congruent? So in the past, what we have learned is that if we can recognize that corresponding angles and corresponding sides are congruent, then we are able to say that the two triangles are congruent. So what we're going to look at is, do we need to know all six parts of a triangle are congruent in order to prove that the two triangles are congruent? So I want you to take a look at this warm-up, this launch activity, and go ahead and work through it. Pause the video, and then when you're done working through it, we will go over it. So pause the video now and attempt it, and then unpause it to see the answer. So it says, are these two triangles congruent? Explain. Do you need all six pairs of congruences shown in order to prove that two triangles are congruent? If so, explain. If not, how much information do you need? So if we look at this, what you'll see is we see that there is an angle here that is congruent over here. We see an angle that's here that's congruent to here. And because we know that those two angles are congruent, we can then say that this angle is congruent to that angle. And so if we want to figure out if this triangle is congruent, then you would need to see, well, are the corresponding sides congruent? So if you look at the angle that has, if you look at the side that is between the angle with one tick mark and two tick marks, you see that it has one line of congruence. So therefore, that is those two sides are corresponding and they are congruent. If you look at the side that is between the angle with 3 and 2, you see that it has two tick marks. So the side between angles 3 and 2, you see it has two tick marks. So that means that they are congruent. And so that means finally you'll see that the side with 3 tick marks is between angle 1 and 3, between angle 1 and 3. Therefore, this triangle is congruent. So we would say these two triangles are congruent because corresponding parts are congruent. So what we were able to do is analyze those two triangles and see, yes, the corresponding angles and corresponding sides were in fact the same size for all six parts. Now the question, do you need all six parts or all six pairs of congruences to show that the two triangles are congruent? You may not know the answer to that. And that's what we're going to look at today. So short answer, no, you don't need to know all six pairs of congruences. And today we're going to look at how much information you need to know and which information you need to know as well. So an example of when you might need to know how to do this stuff, like where it might be beneficial to have some shortcuts to find congruences, are if you think about a building contractor. Okay, so if you have a building contractor and they have just assembled some giant triangular trusses in the ceiling. So if you've ever been in a gym and you see like the beams that are triangles, what they need to do is they need to make sure that those triangles are identical, congruent. And so in order to do that, we need to know, well, what is a quick way to figure out if they are congruent? So that's just a quick example of when you might use this in the real world. Now, previously what we've learned about is we learned about the third angle conjecture, and that is if there are a pair of congruent angles in each of the two triangles, then the third angle must also be congruent. That's kind of what we used up here in the warm-up when we were able to figure out, since this angle was congruent to this angle and this angle was congruent to this angle, then we were able to say, hey, this third angle is also the same size in both triangles. Now, does that guarantee that the two triangles are the same? Meaning, if we know that all three angles are congruent to another angle, and if we know that corresponding angles are congruent, and that's all we only know that the corresponding angles are congruent, does that guarantee that the trusses or that the triangles would be the same size? And the answer is probably not. We probably need to know something about the sides of the triangles in order to say that they are congruent. So what we're going to do is we're going to begin looking for triangle shortcuts for triangle congruence. So here's what we're going to do. We're going to spend the time looking at congruent shortcuts by comparing 3 parts of each triangle. There are 6 different ways that the 3 corresponding parts of 2 triangles may be congruent. Okay, and they're listed below here. You have side, 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 where all 3 sides are congruent. You have side, side, where you have 2 sides and an angle congruent. You have angle, side, angle, which is where you have 2 angles with a side in between them congruent. And then side, angle, side, side, angle, and angle, angle. And what we're going to do is we're going to look at 3 of these in this lesson, and then we're going to look at the second 3 in the lesson for 4.5. So what we're going to do, we're going to work through these investigations, and you can do these on a separate sheet of paper, or you can print out the notes and do them on that. I'm going to use the smartboard, so we're going to use a compass and a straight edge to complete these investigations and look at these different congruence shortcuts. So jumping over to the smartboard, we have our first. So it's a little smaller, so I can make the compass fit this sides. So again, what we have here is we have 3 sides of a triangle. We're going to put them together and create a triangle and see if knowing that 3 corresponding sides are congruent, to see if that's enough, okay, to say that the 2 triangles are congruent. So if you look at it, here's what we're saying. We're saying if you have this yellow triangle and this green triangle, and you know that this side is congruent to this side is congruent to this side, and these 2 sides are congruent, can we say that the triangles are congruent? So let's complete this construction. So here's our initial segment that we need to start. We already have AB measured, so we are going to make our mark here. So we have AB, and then we are going to create BC. So we bring our compass up here, we adjust this so we have BC, and then we're going to, since B was over here, we are going to create our arc. So there's any point on that arc will give us BC. And then now we're going to come over here and we're going to construct side AC. So we adjust our compass. Again, you can follow along on your own notes, or you can do this on a separate sheet of paper. Here's AC, and so we know that after we create this arc, come on, compass. Again, much easier to do this on a piece of paper instead of a computer. Okay, we make this arc. There we go. And now we're going to take our straight edge and we are going to connect one endpoint. And let me adjust this width of this line. There we go. So we're going to take this straight edge and we're going to connect if the computer will cooperate. So we're going to, here we go, boom, that goes there. And remember, we're connecting the point of intersection because that is the only point where these distances match up the way we need them to. So we have triangle A, B, and C. And the question is, really what you're asking is this the only triangle that we can make that has sides of this length? And if you think about it, the answer is yes. Because if you start, if you were to adjust this, like say you move this up here, right? Then you would have to extend this this length of that triangle, and then you start seeing that, you know, these sides are no longer the correct length. So if you think about this, the only triangle that you can create when you're given 3 sides is this triangle right here. You could rotate the triangle, you could reflect the triangle, but regardless, this is the only triangle that you can create with these 3 lengths. So what we say is if we go back to our smartboard or our notes on our iPad, is that if the three sides of one triangle are congruent to the three sides of another triangle, then the triangles are congruent. So this is what we call the side-side-side congruence conjecture. And what this means is if you have two triangles and each of the three sides are congruent to the corresponding sides on the other triangle, then you can automatically say that those two triangles are congruent. And that's your conjecture. And if you think about it, if they're congruent, then that means the three angles are congruent as well, because if two triangles are congruent, that means that they're the exact same size in side length and in angles. So side, side, side. If you have three sides that are congruent on both triangles, then you have congruent triangles. Now, before we look at the next ones, we need to talk about a vocab word, and that is, what is an included angle? So an angle that is included between two sides of a triangle is called an included angle. So if you look at this example right here, you'll see that you have this triangle, or this angle right here, and it is between these two sides, this side and this side. So since we have side and then this angle and then side, that is called an included angle. So when we look at this next conjecture, is this side angle side conjecture a shortcut? What we're saying is, if you have two sides that are congruent, so congruent side, congruent side, congruent side, congruent side, and the angle in between them is congruent, does that mean that the two triangles are congruent? So we're going to jump over to a smartboard and we're going to take a look at this question. So again, what we're trying to say is, if we have this, can we say the two triangles are congruent? So jumping over to the smartboard. Here we go. So we're going to start by creating our initial line. And what we want to do is we need to make sure that when we create this, like when we put point D on this line, that angle D is also there. So here we go. We're going to create line D, or my fault. Let's bring this up here. We gotta measure off DE. So let's make DE. So here we go. Adjust our compass. Bring it down here. We're going to put that there. There we go. And then we're going to create angle D. So let's make this angle. Here we go. We get our arc the right size. We come over here. This is point D over here, so this is where we're creating our arc. We adjust our compass to measure the length of the arc. There we go, just about. Okay. And then we come back over here. We make our second arc to find out where they intersect. There we are. We draw our line segment that connects the endpoint D through that point of intersection. And then we now need to duplicate the segment DF. So here we go, D and F. DF is going to be on this side of the angle over here. We create that, and then we draw in our side that connects those two endpoints. So the question is this the only triangle that we can create that has this side, this angle, and this side as well? So if we think about this, the only thing that's allowed to change, and let me write these in. We have D over here, we have F over here, or no, my fault, we have E over here. So E, and we have F right here. So the only thing that's allowed to change is FE, okay? Because DF has to stay the same, DE we're given, and angle D is the same. So the only segment that can change is DF. Well, if you take a look at this, if we make DF longer, then angle if we make EF longer, then DF is no longer the right length. It would be too long. If we make DF shorter, then we no longer have the correct length for DF. It has now become short. That has shortened the side DF as well. So what you find out is the only way that you can have a triangle that is DF, that has a side of DF and DE and an angle D, the only way that you can have that triangle be congruent is if you have this side be this exact length. Okay, as soon as you start changing the length of FE, you start changing the length of DF or DE, and that is not allowed. It doesn't matter that the angles change, but the side measurement of DF in that case or DE change as soon as you start moving or adjusting that side. So what comes into play and what we're allowed to say then is that if you have a side and then an included angle and then another side that are congruent, then we can say that those two triangles are congruent. So we now have two ways to check to see if triangles are congruent. You have side, 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 and then you have side, angle, side. So again, what we're allowed to say here is if you have a triangle, two triangles, where they have two sides and an included angle that are congruent, then you can say that those two triangles are congruent. So now we have two ways to look at a triangle where all we need is three pieces of information, and then if we have those three pieces of information, we can say that the triangles are congruent. We don't have to worry about finding the other pieces of information, the other parts of that triangle. So let's take a look at the third one, side, side, angle. So if you look at this, you see it's side, side, angle. So this angle, okay, is not included. So if you look at the picture over here, what we're looking at is we're saying, okay, if we have this side over here congruent to this side, and we have this side congruent to this side, and then you have this angle over here that's congruent, can we say that those two triangles are congruent? That's our question. Are those triangles congruent? Meaning, if we construct a triangle with a length of this side, a length of this side, and an angle that is that big, is that the only triangle that we can construct that's like that, or can we construct multiple triangles that follow that have those properties? So we're going to go over to our smartboard. Okay, and we're going to take a look at this third congruence possible shortcut. Again, we don't know if it's a shortcut. We want to figure out if it is. So we're going to create our line, and then we're going to come here and create this side. So we have ST right there, and then we're going to create angle S. So if we want to create angle S, we will flip that over there. No, flip it back over there. We will adjust this, put our pointy end of our compass right there, adjust that like so. There we go. So we're going to bring our compass over here and rotate it. We're going to create angle S at endpoint S, so right there. There we go. And then we got to adjust our compass so that it is the correct length of that arc, like so. And again, the reason we're not printing these out and doing these on paper is because we're assuming at this point you know how to duplicate angles and sides from chapter 3. So this is sort of just doing the process. It is not a bad idea to practice though. So if you want to practice, I recommend that you do that. Okay, so we have our angle created just about now, and then here we go, right there. And then we have TU. So we have S over here. We have T right here. So now we need to find out where U would go. So let's take our compass. We need to duplicate TU. So adjust this like so. Put T right here. There we go. Bring this down. We know T is right there, so we flip our compass, and we're going to make our arc. And what I want you to notice is this arc intersects that ray we made to create that angle 2 times. So what that tells us is that you could put TU here, or you could put TU here. And so what you see is you actually have 2 triangles. Okay, so you have this triangle right here where you go. So you have this triangle where you have these sides right here, S, T, U, like so. But you could also have another triangle. You could also have S, T, U. And if you think about it, everything holds true. ST is still the same length for both of these triangles. TU is the same length for both of these triangles. Angle S is the same sized angle for each of these angles. So you have side, side, angle, but you have 2 triangles. So what that tells you is that you cannot necessarily say that, hey, if I have 2 sides and then an excluded angle, I cannot say that those are congruent, because as you can see here, I've created 2 possible triangles. I don't know which triangle it is. So what that means is, if you jump back to our notes, that is that if you have a triangle, 2 triangles, where you have 2 sides and then an excluded angle, meaning the angle is not in between the 2 congruent sides, then we are not allowed to say that they are congruent. You have what is called the side-side angle non-congruence conjecture. Okay, so and again it says if 2 sides and a non-included angle of one triangle are congruent to the corresponding 2 sides and non-included angle of another triangle, the 2 triangles are not congruent. Okay, they are not necessarily congruent. They might be, but they might not be. We cannot say for a fact that they are congruent with just this information. So what we have now is we have 2 conjectures that we can use to say that 2 triangles are congruent. We have a third that is not allowed to be used. Okay, so to summarize, congruent triangles. You can use side, 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 or side, angle, side. Okay. You can, so not congruent triangles, you cannot use side, side, angle. Okay. So use these, cannot use this. All right. So let's look at a few examples of how we can use these two congruent shortcuts to figure out if triangles are congruent. So if we look at triangle ABC and triangle DEF, it says, and again, when I'm doing my homework, I like to use a highlighter so AC is congruent to DF. And then we have, it says BC is congruent to EF. So BC is congruent to EF. So you see 2 and 2, 1 and 1. And then finally we have, it says AB is congruent to DE. AB is congruent to DE. So what we have here, it's asking, is angle B congruent to angle E? Well, first off, we know that triangle ABC is congruent to triangle DEF because of the side, side, side conjecture. Corresponding sides are congruent. All 3 corresponding sides are congruent. Therefore, we can say that because of the side, side, side conjecture, those 2 triangles are congruent. if the two triangles are congruent, that means that we can say corresponding angles are congruent. So angle B corresponds with angle E, so angle B is congruent to angle E. You could also say angle A is congruent to angle D, and angle C is congruent to angle F. All right. Now, if you come down here, it says which triangles are congruent, identify the congruence conjecture that explains why. So remember, in this lesson, what we've learned is you can use, to figure out congruency, you can use side, 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 and you can use side, angle, side. So we're looking for triangles that have 3 congruent sides, and we're looking for triangles that have 2 congruent sides with an included congruent angle. So if we look at so first of all, let's look at these 2 little triangles. Obviously, this little triangle can't be congruent to this big triangle because they are clearly not the same size. So we're not looking at those. So the question is triangle ABE congruent to, is that congruent to triangle BEC? So if we take a look at this, actually, let's rewrite that. So corresponding sides, so you'd have C, so this would be triangle CBE. All right, so if you take a look at this, side AB, is that congruent to CB? Check. And then if we have AE, is that congruent to CE? Correct, it is. And then finally, what about this side of the triangle? Is this side of the triangle congruent for both of these triangles? And the answer is yes, because these 2 triangles share that side. Therefore, it has to be the same. So we can say that ABE and triangle CBE are congruent because of the side, side, side. If I could write a third S, side, side, side conjecture. Okay, so yes, they are congruent. We can get rid of that question mark. It's no longer a question. The side, side, side conjecture says they are congruent. Then if you look at these other 2 big angles, you see that you have, okay, so first of all, we cannot say anything about this third side. We don't know. All right, there's no way to, right now there's no information about that side. But here's what we do know. We do know that these 2 big triangles share side ED. So we can say ED is congruent. We also know that they have this angle, this AE and EC congruent. So our question is, can we figure out this third side? And if not, can we figure out if there's an included angle that's congruent? So first off, the answer, if we had numbers, if we knew the lengths of these sides, we could use Pythagorean theorem to figure out whether or not that third side is congruent. However, there are no numbers, so we can't use Pythagorean theorem. So we have triangle A, E, and then D, is that congruent to triangle CED? Okay, question mark. So the answer is yes, because what we know here is since this angle is 90 degrees, this angle is 90 degrees, this angle is 90 degrees, and this angle is 90 degrees. So what we can say is that this triangle, AED, we can say angle E is congruent in this triangle and it's congruent in this triangle. They're both 90-degree angles. So what we have is we can say yes, these 2 triangles are congruent because of side, angle, side. Angle E is included between side A and side AE and ED, and is included between CE and ED. And so since those 2 angles since that angle is included between those sides and it's congruent in both triangles, then we know that side, angle, side means that those 2 triangles are congruent. So it's no longer a question, they are congruent. Now, it says in this next example, if side AC, so here's side AC, we'll highlight this, if AC is congruent to DE. So if these are congruent, and it says if AB is congruent to DF, right there, and angle C is congruent to angle E, can we say that these 2 triangles are congruent? And the answer would be no. Why? Because that angle is not included. All right, angle C and angle E are not included. So this is an example of side-side angle, which we know which is not a congruence shortcut. Okay, so therefore we are not allowed to say that these two triangles are congruent. No. All right. So that is how you can use these three. This is how you can use these two and not use this third shortcut to be able to prove that triangles are congruent. So you're going to go ahead and work on your 4-4 homework. Pay attention, odds and evens. And if you have any questions, message me on Remind or through email, or if you have questions on the homework, please ask them in class. So I will see you in class.